My slides are visible?
Yes, sir.
Fine.
Clear.
Then I can start now.
Yes.
So I'm audible and slides are visible. Everything is fine?
Yes, sir. Clear and
Okay. Okay. Good afternoon to everybody. And thank you, VIT Mesra, for inviting me to deliver a talk on remote sensing for ocean dynamic studies and climate change effect. Basically, it's a very broad topics. It is very difficult to cover in maybe 1 hour, 1.5 hours, but I'll try to see to justify the topics, and as much as possible, I'll try to cover. And also, I'll be trying to tell you about the issue pertaining to coastal zone, because coast is a part of the ocean, and majority of the people, they are living in the coast. So what is the effect of the coastal zone also I will try to highlight if time permits. So first we'll see that what are the ocean contributes for our civilization, for our daily life. If you see that why we need to conserve the ocean, why it is needed, why we keep ocean, why we need to study ocean. So I have written down few bullets, but still there are much more bullets may be written, but only the important bullets I have written over here, so that you can have some certain ideas. Maybe some of, I don't know, but maybe some of you are already experts in oceanography. They are studying, but maybe there are people who has not studied ocean that much. So for them it will be good. So ocean makes up around 70% of our planet, that you all know, and it provides various services to the human being. So it generates oxygen, it generates food for us. This is very important. It stores excess carbon dioxide. So as you know that ocean is one of the biggest sink for carbon dioxide. So all excess carbon dioxide stores in the ocean, and also ocean is responsible for various kinds of weather event. We'll see afterwards. But of late, increasing greenhouse gas emissions threaten the coastal and the marine ecosystem. And because it changes the ocean temperature is rising, and because of rising temperature in the ocean, there is various effect. One of the effect very popular is coral bleaching. Also, there is melting of the ice of the poles and the Antarctic ice. They are melting, and the water is being coming to the ocean, and they are mixing with the ocean, and sea level rising is happening. And also ocean acidity by the excess carbon. So because of the increase of temperature, the carbon is getting in the solution, and it makes ocean water more acidic. We call the ocean acidification, and that also creates a lot of issue with the ocean ecology, particularly the seagrasses, corals. And when global ocean is concerned, because the topic is on the climate change, we will be seeing that global ocean is experiencing various issues when climate change is concerned. Because climate change is not a myth now. Climate change has been proven in the various form, like rising of temperature, like rising of the sea level rise. So climate change, if you go through the IPCC report, you can see how the greenhouse gas is increasing with time, how the temperature is increasing with time, and what are the effect of all this. So because of the climate change, it increases the air and the water temperature of the ocean. It also causes issue with the ocean ecology, and also the coral bleaching. Coral bleaching, and also because of the increase of temperature, it shifts the various species from one place to another. Because of the, as I was telling you, because of the melting of the ice and mixing of the ice melt water with the ocean, and also thermal expansions of the water, it causes the sea level to rise. And because of sea level rise, there will be increased coastal erosion, and also inundation of the low-lying areas like coastal mud flats, coastal wetland. they will be inundated. So we will be losing land because of the sea level rise. Local flooding will be also happening. And there are also various issues relating to hypoxia. Hypoxia means we call about it's a dearth of oxygen in the ocean water. It happens because of the algal blooms in certain places, and that mainly because of the coastal pollution effect. It has been seen because of excess nutrients. A lot of algals they grow tremendously, and algal blooms happening, and that creates hypoxia. And because of lack of oxygen, a lot of marine fishes and other animals they die. The marine diseases, a lot of marine mammals and the fisheries, they're the all issue with the climate change and related phenomena. And also because of the climate change, there is a change in the level of the rainfall. And because of this, some places there is a flooding, some places there is a drought, and there is also increase of the storm surges, cyclone because of the climate change. So earlier we all know that there are a lot of cyclones in the Bay of Bengal. Bay of Bengal cyclone frequency is much more than the Arabian Sea, but of late you have seen very recently there are few cyclones they are happening in the Arabian Sea as well. That means also we call the sea surface temperature. Sea surface temperature is overall increasing in the Arabian Sea, which is one of the prime factor for causing the cyclone. Also, there is a term we call the blue carbon. That is the carbon dioxide captured by the world ocean and the coastal ecosystem. That is a very latest topic. People are now working on the blue carbon issues. And this carbon is stored in the form of the biomass of the various planets like tidal marshes, mangroves. Very important because mangrove is the one of the evergreen plantation in the coastal area, and where the biomass is very high. So the carbon is stored in the form of the biomass and the sediments, which are coming from the mangroves, tidal marshes, and also from the seagrass meadows. So you can see that why the ocean is important, and because so much of factors are related to the human civilization and human livelihood. Now, also, I'll continue with few important facts about the ocean because that will drive my lecture afterwards. So it is covering, as I told, around 70 to 71% surface of the Earth. Also, it is having 1,100 times more heat capacity than the atmosphere. It contains 90,000 times as much water as atmosphere holds. So it's a huge water storage. And also because the ocean is almost 70% of the surface of the Earth, obviously the global precipitation around 78% is being received by the ocean. The ocean also, as we were discussing, because of the climate change, also there is the effect of the ocean. At the same time, ocean also affect the climate through its huge capacity of water and the heat associated with the water. So it has around 97% of the all Earth water, and 86% of the total evaporation happens. The upper 3 meters of the ocean has the same amount of heat as the entire atmosphere. Only upper 3 meters of the ocean, the amount of heat it contains, it is the entire atmosphere, the amount of heat it contains. So you can imagine the amount of heat contained in the ocean water. So it absorbs around 84% of the heat from the global warming. So it's like a ocean is such a thing that it absorbs all various negative aspects of the atmosphere and the other issues created by the human being. So ocean is like a savior for us. Now, as we know, the global warming is happening. So that's why it has been seen that from 1860, global average surface temperature is rising. 11 of the warmest years recorded since 1990, and 5 warmest years occurs in the last 10 years. It is mainly happening because of the industrialization. Once the civilization started, industry started, global warming has been tremendously, it has been increased. Average global temperature, it is rising around 0.6 degrees centigrade over the past century. And accelerated during the past 2 decades is around plus 1 degree centigrade per century. That means tremendous rise in temperature because of the global warming, which has created a lot of issues when climate change is concerned. Now, this histogram will give you a better picture that amount of heat, how much of heat is being absorbed by the world ocean. So it is the number you have to multiply with the 10 to the power 22 joules. You can see the world ocean, see the red histogram. It is around, out of 18, it is around 14.5 is by the world ocean, and only 0.9 into 10 to the power 22 joules is by the continent, and accordingly by some by glacier, some by atmosphere, some by Antarctic ice sea, like this. So majority of the heat has been absorbed by the world ocean. So you can see the how the global temperature is changes with time, and this is the graph how the temperature rising is affecting. You can see the continuously the graph is rising from 1880 to 2000. How the graph is rising, and you see the rate of rise is tremendously high. If you see the year from 1990 to 2000, more industries are coming up and more anthropogenic effects are happening. So temperature rising is becoming too much. And when this is the basically global temperature rising we are talking about, but when we talk about the sea, we talk about the sea surface temperature. So the next graph is about the 100-year record of the sea surface temperature change in the North Atlantic Ocean. You can see how the sea surface temperature is also again increasing with time because of the global warming and the other issues, and because of the increase in the sea temperature, there are a lot of changes are happening in the coastal marine ecology. Particularly, we will be seeing that how increase in SST is increasing the frequency of the very high magnitude cyclone like super cyclones, and also causing ecological issues like coral bleaching, and also mortality of the various kinds of ocean animals, ocean mammals because of the increase of the SST. And you know, one of the major greenhouse gas is the carbon dioxide. You can see the certain model derived output. The sea surface temperature, if it is more, the temperature of the atmosphere will be increasing more. So that means global mean air temperature, it has been showing here. In some region, it will be 8 degrees centigrade to 11 degree warmer if carbon dioxide becomes doubled. And if it is become 4 times, what is the present scenario, then using this model we call GFDL model, that it has been seen that it's a global model. It has been seen that few places the temperature will be around 13 degrees centigrade warmer. That means you can understand if a temperature, atmospheric temperature increases by 10 degree to 13 degree or 11 degree. So what is going to the effect of the human being and the other species? So the top one is if the temperature is increasing by this is a graph, the color you can see. So if it is increasing by twice of the carbon dioxide what presently it is there, and if it is 4 times, you can see everywhere it is all red color. So that means the temperature is increasing around 15 to 20 degrees centigrade temperature. Now this is all about the regarding little bit introduction of the ocean part. As I told you, also the coastal zone, I will be trying to highlight some of the coastal studies also, because that is the area where I have done some amount of work. So I thought, because, and also the coast is a part of the ocean, and the coast is the area where human beings are living at the coast only. So if something is happening in the coast, direct effect is visualizing on the human. So when coastal zone is concerned, basically we tell it is a part of the ocean and part of the land. So it is a transitional area between the land and the sea. So when we talk about the coastal zone, we talk about that it is an area. Pardon me?
इसका क्विज भी आप ही दे देना।
Excuse me.
कर लोगी ना? मैं चाहता हूँ हर चीज।
Any problem?
मिलके कर लेंगे।
Please mute your mic.
अच्छा तो हटो अभी सोने दो।
Participants, mute your mic.
Yeah, it will be nice if the participants mute their mic, because I am getting some background noise. Okay, so I was talking about the coastal zone. It is basically, as I told, it is a transitional between land and the sea. So part of the land and a part of the ocean comes under the coastal zone. So it is an area rather than a line. When you talk about the line, we talk about the land and water boundary. That is also very important. I'll come afterwards. So, but here the coastal zone we are talking, it is an area basically. But that means in a GIS, you know, if I digitize the area, it will come as a polygon. But when I digitize a line, it will come as a polyline or the arc. Okay. And the coastal zone width is not same everywhere. It is varying from the place to place, and it is determined by the interaction of the marine and the terrestrial processes or the land processes. If the land processes are very strong, if it is acting very strong over the ocean, then your coastal zone will be very narrow. But if the oceanographic processes are very strong, so it will push back the coastal area far deep inside the land. So the coastal zone is not same everywhere, even when our Indian coast is concerned. So in the as I told, ocean is around 71% of the total Earth's surface. But out of this, the coastal zone is occupying only 18% of the Earth's surface. But out of this, if we see that the world coastline, it is around 1 million kilometer long coastline. Out of this, only 40% is accessible. People can live, go there, and temperate enough to be habitable. People can stay. But yet, this coastal zone is occupying 60% of the world population. That means the area is small in the coastal zone, but huge population is living in the coast. Because, as we know, if you see the prehistoric time, our civilization started at the coast. First of all the big expeditions like Job Charnock, Columbus discovered America. They all came to different that time different land masses. Better if I call it land mass through ships through voyage. Okay, over the ocean, and they started living in a particular area of land mass in the coastal area. So civilization started at the coast, then slowly it is migrated towards the land. So from the prehistoric time, people started living in the coast. So now it has been seen that around 60% of the world population is living within this 18% of the surface of the globe. That means population density is very high in the coastal zone. So as I told, 18% of the surface of the globe is by the coastal zone, and 60% of the world population are living. Two-thirds of the major cities of the world, they are lying in the coastal zone. If you see in India, except Delhi, major mega cities like Chennai, Kolkata, Mumbai, and also other major cities like Vizag, so they are all lying, Ahmedabad, they are all lying in the coastal zone only. And density, as I told you, it is 6 times higher than the non-coastal areas. Another very important point is 90% of the world fish catch, they are coming from the coastal water, because coastal water is very productive. Productive in the sense there are a lot of phytoplankton. We call them chlorophyll, microscopic plants. So they are the food for the fishes. Okay, and this increase of the phytoplankton in the coastal water mainly because of the rivers brings a lot of nutrients from the land, and they dumped the nutrients in the coastal water. So fishes love to be in the coastal water, and also temperature of the coastal water is suitable where the fish can stay. So we'll be seeing when we'll talk about the potential fishing zone from the remote sensing data and other aspect. So we'll see the how the coastal water contributes to the overall the fish catch. So 90% of the world fish catch coming from the coastal water. As I told, coastal water is part of the land and part of the coast is part of the land and part of the ocean. 8% of the ocean surface. Out of like if it is 70% of the total land surface, total surface of the earth, out of this 8% of the ocean surface comes under the coastal zone. 75 to 80% of the global sink of the suspended river low. Lots of the sediments also are being brought by the rivers and they deposit in the coastal area. They may form as a estuary, or sometimes it has been seen they form huge deltas. Like in the west coast, in our Indian coast, you will find estuaries, but in the east coast, you will find very important deltas. So 75 to 80% of the global sink of suspended river load are happening in the coastal zone. And that is why the coastal water, you will see always it is very turbid, because of the lot of sediments are being brought by the rivers. And also it causes a lot of erosion neighboring coastal area. So that's eroded materials also mixing with the coastal water. So coastal water usually, except few places, mainly in the areas where you will find corals, there the water is very transparent. Hardly there is any sediments. 90% of the global sedimentary mineralization are happening in the coastal zone. Now, this is the population density when the world map is concerned, and you can see the red color where the population density is more than 100 kilometer, 100 people square kilometer. You can see our country, the Sri Lanka, the Bangladesh, the Malaysia, the Indonesia, the Thailand. So these are the countries where the population density is. All the Asian countries' population density is tremendously high in the coastal zone, and because of high population density, lots of people are living. So they have to earn their livelihood in the coastal zone. So lots of activities that you will find in the coastal zone. So no area in the other land area you will find so much of activity. I will show you maybe in the next slide that so much of activities are happening in the coastal zone, and because of this so much of activities and the dynamic nature of the coastal zone, there are a lot of effect that are happening in the coastal ecological form. So this is little bit of geological side, basically. Basically, in the ocean, basically you will find the energy. This is coming mainly in the three waves. They are the waves, tides, and the wind. And also the waves where it is very dominant. So then you will find like landforms classes. You will find the cliffs on the smooth platform. That will there the really the coastal erosion feature. You will find that it will cause the cliffs and the shore platform. But where the wave energy is less dominant, there you will find the more of deposition. So you will find coral reefs. You will find the beaches. You will find the mud flats. Those things you will find where the wave energy is less. And also, so this is from the geological structure, particularly, and when the materials are concerned, if the materials are whether the materials are marine or materials are the coarser material or materials are the finer material. If the materials are marine materials, then definitely it will form coral reef. If the materials are the coarser, mainly the sand particles or the pebbles or cobbles, they will find beaches. If there are the finer materials but less wave energy, depositional areas, you will find tidal flats or the mud flats. And also the coastal materials, some places you will find coastal sand dunes. So they are the mainly the, so when in the coastal zone, when energy is concerned, we get the energy from the waves, from the tides, and from the winds. Basically, winds basically the driven force who causes the waves. And because of these winds, it depends on the overall geological structure, the materials that will govern you. But what kind of coastal structure, whether it is cliffs or you'll find beaches or you'll find mud flats, they're basically governed by various kinds of energy regime in the coast. This is all, our country. These are the coastal states of our country. Like in the east coast, you will be finding Bengal, West Bengal, the Odisha, then Andhra, then you will find Tamil Nadu, then we are finding Pondicherry. So these are the in the east coast. There are same few states are in the western coast. So we have 9 coastal states, and also there are certain coastal union territories. There are 4 coastal union territories. So these are the what is the total coastal state, and we have around 7,500 kilometer long coastline. So compared to world, we are in 19th position when coastal length is concerned. And people in the world, it has been seen that 60% of the world population is living within the 100 kilometers of the coast. So huge amount of people are living in the coast when entire globe is concerned. 35% are Indians are living within 97 kilometers of the coast. And another very important point is that 10% of the world population is residing in the LECZ, that is the low elevation coastal zone, where the elevation is less than 10 meters. Because this is the area I'm specifically mentioned. This area is highly vulnerable for various kinds of hazards like cyclone, tsunami, storm surge, any kinds of hazard. First, it is going to affect this LECZ. And in this LECZ, 10% of the world population, there is a huge population are living in this in the LECZ region where the elevation is very, very less. And when coastal resources is concerned, around 120 million people in the world directly depend upon the coastal resources. The huge population they are depending on what are the coastal resources are there, and they are using the coastal resources. And I'll be sometimes I should tell that they are exploiting the coastal resources rather. because usually whatever you need to live, we try to get more whatever actually we need. So we exploited the resources, and 9 million Indians directly depend upon the coastal resources. Mainly they are doing fisheries or other aquaculture business for livelihood. Now you see, when coastal biodiversity is concerned, it support a huge number of flora, around 25,000 flora and around 4,700 fauna. Our coast supports around 970 plant and 305 animal species. Few species are highly specialized and endemic, and also coastal zone is also include the ecologically sensitive areas. And our coastal zone has a wide range of habitats you will find. You can see we have a good sizable amount of coastal wetland. We have 7 major estuaries, good amount of lagoons, around 17 lagoons. Out of these, 8 in the east coast and 9 in the west coast. We have around 5,400 square kilometer mangrove area, but majority of the mangroves you will find in the east coast area because Sundarban is there. So 56% is covering in the east coast, around 32% in the west coast, and Andaman is around 12%. We have a good amount of corals in for 5 places. That's around 1,400 square kilometer. And marine protected areas around 6,000 square kilometers. This is what we have in our coastal area. And you see the different activities in the coast. Industries are coming up, lots of quarrying activities, sand extraction is happening, oil extraction, agriculture activity, forestry activity, urban areas are coming up in the coast. Lots of tourists are flocking in the coast, fish activity, lots of defense and military activities in the coastal area, irrigation. So you can see that I have listed so much of like dredging activity for coastal channel, for the coastal port areas, dumping, waste dumping in the coast, deep sea fishing. So much of activities I have noted down which are happening in the coast. And all these activities, it has been seen that there are certain impact on the coastal ecology. And it has been seen that here the ecology is intertwined. Intertwined means we saw that they are related with such a manner, like if you cut the mangroves, it basically is not only the mangrove ecology. This in turn is going to damage the associated various kinds of ecological parameters. Okay, like if you damage the coral reef, then it is going to impact the near shore coast water quality. It also going to affect the lots of fishes ecology, small fishes, lots of other algal ecology. So this is such an important element, the coastal zone, and such a complex and the fragile ecosystem. So we should try to always conserve the coastal ecological part. This is what this is satellite data, WIPS data of our country. As I told you, we have around 7,500 meter coastline. The east coast is mainly you have a good amount of deltas in the east coast, good mangroves, Sundarban, Bhitarkaniaka in Odisha, Pichabaram in Andhra. We have a saline lakes like Chilka, Pulicat, we have Gulf of Mannar. In the west coast is basically narrow coastal strips. We have estuaries in the west coast. We have like Narmada, Sabarmati, Mahi, Dhadar, those kinds of estuary were getting in the west coast. And also we have a Gulf, like Gulf of Kutch, Gulf of Khambat in Gujarat. We have several ports in the west coast, limited coral reefs like in Gulf of Kutch, and also in the Malban coast, bit corals, and also good amount of mangroves also there in the west coast, but not same like east coast. Andaman Nicobar, they are mainly we have found dense forest, meandering saline lakes, and the corals you will find. Lakshadweep Islands, they are mainly the atolls. You will find lots of good healthy corals, and we have 14 marine and the coastal protected areas. Now, when Indian coast is concerned, basically you can divide from the satellite data using the major feature which is available on the coast. Like we can find it if the coast is, you will find if it is an open beach or the rocks are exposed or cliffy coast, we will call it as an open coast. Okay, so like I am showing you the color where you will find the open coast. If whether the corals are there, like you see the Gulf of Mannar, the Lakshadweep, the Andaman Nicobar, the Gulf of Kutch, whether corals are there, we will call it as a coral reef coast. Whether there are a lot of estuaries it is forming, so they are the estuarine coast. As the deltaic coast where delta is formed, so they are the deltaic coast. Kishangadurbi Delta, then there is a Sundarban Delta, So they are the important deltaic coast. So we'll find that the delta coast where they will find lots of mangroves are there. So we'll call them as a mangrove coast. And using certain remote sensing data, I'm going to come. So you can classify the coast, the different coastal landforms and also land uses. And you can make this type of pie chart and you can show the area, how much is a mud flat in a particular coastal area. The entire national level classification is possible, and this type of classification has already been done, and atlases are available using satellite data in 1:50,000 scale. So like how much mangrove is there, how much mud flat, how much is beaches, how much is algae present, how much is coral reef, how much is lagoon, how much salt pan, how much dunes. So all these different features you can pick up from the satellite data. So this much of studying the national level is very difficult if you think that I will do it using field survey. It's very difficult to cover such a huge coastal area. So satellite data plays a very important role for making inventory of in the national level scale. And there are lots of issues in the coastal area. As I told that there is a huge population pressure, and there is a direct anthropogenic pressure over the ocean, also effect in the coastal zone. Direct pressure by the you can see the picture from the Mumbai coastal dwellings. They're coming huge buildings very near to the coast. They basically against the rule of the coastal regulation zone. Lots of coastal infrastructure, lots of coastal ports. You can see the urban areas coming up near the coast. Lots of coastal mining activities are happening. They aggravate erosion, coastal mining. So dumping of the sewage from the various factories in the coastal water. They polluted the coastal water and creates a lot of issues with the coastal ecology. Now, there are certain kinds of natural phenomena also there in the form of coastal hazards. Like you can see, we can divide it. One is a very slow onset hazard and rapid onset. Slow hazard means the hazards are chronic hazards. So they will come, they'll remain there for several years, but slowly they will eat up the coastal area, like shoreline erosion, sea level rise. Slowly, it will eat up your lands. Saltwater intrusion. Slowly, the water, the good potable water will be diminished by the intrusion of the sea water, and also land subsidence. You can see the picture and rapid. Like there are storms, there are coastal flooding, so they come and they go. Like cyclone, there are tsunamis, there are storm surge. So they come immediately, maybe in a few minutes time, or maybe some half an hour time. They'll come and they'll go, and they'll be creating a lot of havoc within this. But these are called, as I can see the picture, erosion, saltwater intrusion, sea level rise, land subsidence in the coastal area. So they are the chronic disasters, we call it. These are the various critical coastal habitats like mangrove forest, like coastal mud flats. You see the vital coastal habitat. These are the olive red turtle in the Gairmata beach in the Odisha. They lay their eggs in the coastal zone, so they are the endangered species. So we need to protect them. It is very, very important to protect them. So basically, when coast is concerned, we are talking about the various kinds of coastal issues. They are basically the issues we need to address them when we plan a coastal zone management. Okay, coastal zone management plan, when I'm talking about the integrated coastal zone management, we need to address these issues. And these issues are very common throughout the developing countries in the coastal area. Almost issues are all same. You can see I have given certain numbers, and the numbers have been written over there on the coastal area. So and the various numbers represent various issues. So I'll just see what are the various issues. Like one of the major issues is the coastal erosion. So we are losing a lot of coastal land because of the coastal erosion. So a few places there are certain like urban areas, or there are certain hotels, or there are certain industry, or certain for some other factories there. So their future may be at stake before if the erosion becomes rampant. And the erosion becomes rampant when there will be cyclone, there will be tsunami, storm surge, more erosion will happen. So this is one of the major issues: how to protect your coast from the erosion. Then there is a degradation of the mangroves, and the coral reef ecosystem is happening everywhere. So like mangroves are being cut for industry, mangroves are being cut for setting up the aquaculture, mangroves are being cut for some port activities. You maybe all read in the newspaper. Also, coral reef degradation. Corals are degraded because of the, I told you, ocean acidification, because of the global warming, increase of the ocean temperature. So coral bleaching is happening. Also, sometimes the anthropogenic activity, they also cause harm to the corals. There are a lot of natural disasters in the coastal zone, like cyclones, storm surge. I'm mentioning these things. And one of the major issues is the population. We are the second largest populous country in the world. Huge population is living in the coast. So if the population is less in the coastal zone, your half of the problem will be solved. Then definitely there will be less pressure on the coastal resources, their ecology you can protect. But because of the population, because of the life, they have to because so much of people they have to earn their bread and butter from the coastal resources. So that is a huge issue, huge problem. And also there are impacts of the ports and harbor in the coastal zone because they also create sometimes a lot of. It has been seen whether there is a port is coming up or harbor is coming up, a lot of suddenly erosion activity has increased because it's basically the ports and harbor. They basically creates issues with the longshore current. Basically, sediment budget get disturbed, and that's why suddenly erosion will be more. It has been seen in the Paradip port, in the other port also. There are the issues. There is the more of the anthropogenical, like municipal sewage, wastewater disposal, industrial effluent, solid waste disposal. So what we feel human being that if whatever the waste we are generating, let us dump in the ocean. Ocean will take care of its own, but it cannot take care like this because all the water highly toxic. They pollute the coastal water. That water finally with wind and with the tides, they will go in a far deep distance and they will create havoc in the neighboring area, the coastal ecology. Lots of mangrove will be died, coral reef will be died, lots of other elements, plants, fishes, they will die because of the pollution. Coastal mining, sand mining, and other mining issues for the making the houses and other things, they creates lots of aggravated erosion because again it creates issue with the sediment budget, and also the lots of coastal constructions are happening in the coast in the form of industry, or also in the form sometimes we create certain coastal construction to protect a particular area of the coast. Like I want to protect my beach, I may set up a seawall or a groin or the breakwater. But you may protect your beach. It has always seen when you set up a certain groin structure, your beach will be protected. But obviously, that the downward side of the groin, the water which will go, that will be devoid of sediment. So it will start scouring the land just from your neighbor's beach. So your neighbor will be losing land. Maybe you will protect your land, but so same thing happens with the like breakwaters. Some part of the will be you will be able to protect some part of the coast, but not the entire part of the coast with the seawall and other structure also like this. So they are mainly the engineering construction, but there are certain positive side and certain negative sides. In case of the seawater is one of the major issues when getting potable water at the coastal zone is concerned. It has been seen because of the sea level rise or the unscientific ways of withdrawal of the groundwater from the coastal aquifers nearing the coast. We are inviting seawater to go deep penetration over the land. So in the Bhavnagar coastal area, we have done considerable amount of work. It has been seen there are evidences of saline water intrusion far deep, around 25 kilometers away from the coast. Because there are lots of areas that people are making salt pans where they are pumping the local groundwater, and more pumping is happening. We are inviting the saline water to go deep inside the land through the coastal aquifer, and they are replacing the fresh potable water. So the tube well or the pump where you are getting fresh water for so many years, suddenly in the fine morning you are seeing we are pumping water. The water is saline water which you cannot drink. So that is one of the issue which needs to be considered when coastal zone management is concerned. Now, reduction of the sediment supply in the coastal zone, sometimes it is happening because of the upland dam along the major rivers for agriculture purpose or other purpose. So then the water they are releasing in the upland side of the dam, all the sediment get deposited. So whatever the water is coming devoid of any sediment. So again, I am telling you the sediment budget get disturbed. Okay. So in that case, again, it will started eating up the neighboring areas so that more sediment come into the system. And of late, there are effect of the tourism. There are a lot of negative activities. A lot of nonsense used to be done by the lots of tourists. It is not that all tourists are same. There are certain wise tourists. They don't create any issues with the coastal zone. They will come, they will enjoy, and they'll go back. But there are certain tourists. They will create problems with the coral reefs, with the mangroves, and also they will litter with the plastic and other things in the coastal zone. So there are the other issues with the tourism activity. Now, with all those sorts of stories, I try to come up with the remote sensing, particularly when ocean is concerned, basically what are the various parameters from the ocean we can get from the remote sensing, and how we can study the ocean dynamics particularly. So as you know, all what is the remote sensing is basically it will try to get idea of any area or any feature which is not directly in close contact with you. We are not touching them. Okay, it is a basically interaction between the matter and the electromagnetic radiation which is coming from the sun. If it is a passive sensor, if it is an active sensor, it will be having its own source of illumination. Now, what are the important parameter I can get? Like you can see the ocean color. Ocean color is basically very important to tell about how much phytoplankton is there in the ocean, how much chlorophyll there is in the ocean. So it will get from the various kinds of visible radiometer within the range of 0.4 to 0.8 micrometer, and in a spatial resolution of the various kinds of sensor which give you ocean color, it varies from in passenger context. It varies from 250 meter to around 1 kilometer. And it basically takes into account the absorption and scattering of the sunlight by the sea constituent. Okay, from there we develop the algorithm. We try to understand the phytoplankton concentration. Another important parameter of the ocean which I get from the remote sensing is the sea surface temperature. Sometimes we call it skin temperature, only few centimeters of the ocean surface. So that we will get from the infrared radiometer in the wavelength between 3 to 12 micrometer. And also the microwave radiometer will get microwave radiometer. Basically, that works in a frequency domain. It is a 4 to 11 gigahertz, and the infrared radiometer scale is 1 to 4 kilometer, where microwave radiometer 25 kilometer. So it is basically how it gives. It from the infrared radiometer, we study the emitted infrared, and for the microwave radiometer, basically we talk about the microwave radiation. Same way, I'm not reading everything from the slide. Same way, you can get information about the ocean wind from the scatterometer data. We can talk about the ocean surface topography. That also we will be able to know from the satellite remote sensing for the surface topography of the ocean. Various kinds of altimeters are available nowadays. Soral Altica, Oplet. It's a French altimeter, but went through our satellite only. And also there are the JSONs. There are earlier Topex Poseidon. So there are altimeter. Working in the 5 to 36 gigahertz, so they give you ocean surface topography information. We can get to know information about the sea ice, how much sea ice is there. Also, we will have information about the sea surface salinity called SSS. That is basically you get to know about that from a passive microwave radiometer of 1.43 gigahertz. That particular frequency is important, which will pick up the sea surface salinity information around 50 kilometer spatial resolution scale. As I told you, it is written now, the 1.43 gigahertz frequency is sensitive to salinity changes in seawater. So you can do the salinity mapping. It is also very important. So these are the various parameters of the ocean. In the ocean part, in the water part, we get to know from various kinds of satellite remote sensing data. But next, my question will be: are satellite alone enough? Is it that satellite you can get everything from satellite regarding ocean study or the coastal study, everything from satellite? Definitely, there are certain advantages. Like it will give you a synoptic and a repetitive coverage in a large area I can see, and in a different time domain I can see. So I can see an area 10 years back using old satellite data, and 5 years back, and what is the present scenario. I can get a repetitive coverage. And that is better than in a very sparse and isolated in situ data. If you collect in situ data, entire area, it is very difficult to cover. So there will be certain kinds of in situ observation, but the in situ observation instruments are very sparse, limited. Okay. And there are certain areas, those areas are inaccessible to ships or field work. You cannot go those areas. The ship cannot go to do survey in those regions. So those regions also I can see from the satellite data. Certain parameters like sea surface height, they can be only available from the satellite data. So these are the parameter. There are certain other parameters which you can get only satellite data. But obviously, there are certain kind of disadvantage if you rely only on satellite data. It only gives you the surface measurement. It cannot go very deep inside the land. It cannot go. It will give you only the whatever is there on the surface. Though it has a certain penetration in the water part, but only the land part, it will not able to penetrate much. some parameters are still not available from satellite. There are certain parameters which still satellite cannot give you. You need to do further research where those parameters which are being given by the field instrumentation we can get from satellite data. And also there is issue with the spatial and the temporal resolution. Some satellite data, the spatial resolution is very coarse. So because of the very poor spatial resolution, sometimes we may miss certain information. And also the temporal resolution. Temporal resolution is a issue. Particularly the area, if the area is very dynamic, particularly in the coastal area where things are changing every day or in a hour time or in a minute's time, satellite data cannot capture because the temporal resolution maybe in a day's particularly when I'm talking about the remote sensing, the sun synchronous satellite, geostationary satellite in your every 30 minutes or every 25 minutes in the same area, you can always get information from a geostationary platform. But when remote sensing is concerned, the temporal resolution it may be varies from like ocean color monitor every second day, like you can get information. But like list release for there 22 days, 20 days, sometimes 50 days. Those type of temporal resolution is there. By that time, within the gap of 15 days, lots of things may happen that may you may be able to catch up. So there is a need for the satellite data for in situ measurement, like quizzes. So that's why we talk about the integrated ocean observation system. It is a space-based and the in situ long-term observation network is needed. Okay, for this, like you see, satellite system. We have a ocean color. I was talking about the ocean set data. That's give you information about the ocean color. They will give you the chlorophyll information, ocean suspended sediment. We call the SSC, suspended sediment concentration. It will give you the surface wind or SST from the MSMR data of the ocean set 1. Afterwards, we got the ocean set 2. Ocean set 2 also give you information of the surface wind. It will give you also information about the ocean sediment, the chlorophyll. We have a Sorrel Altica, I was just telling you, it was giving you the sea surface height, SSH, the currents. We have a geostationary platform, it's a 3D imager that will give you the sea surface temperature at a very particular location. Continuously measurement is possible. And also in the future, we are hoping towards ocean set 3 and the other sensors. But you can see the in situ, also there are lots of in situ measurement in the ocean. Basically, there are lots of in situ measurement, like there are various kinds of floats, like Argot floats, there are lots of buoys, like Rama buoy. There are various kinds of sensor like CTD, conductivity, temperature, and we can say the density. There are XBTs, and there are lots of other instruments. They are deploying throughout the world ocean. You can see around the Indian Ocean, there are lots of sensors they are being deployed, and those sensors they are continuously giving data. Like when I'm talking about the buoys information, particularly the Argos floats, they will give you information about the temperature, salinity, and their vertical profile you will get. Same thing we'll get from the Rama buoy. Also, there are various kinds of ADPC float or the Argot ADPC meter. There is the Argot float. So they will also give lots of information. Particularly, there are so many tide gauges. There are bottom pressure recorder. They also give information. Lots of information you will get, particularly in the Enquest site in Hyderabad. They deploy lots of instruments. Lots of information has been deployed by NIOT in Chennai. So lots of information is also available because these in situ instruments are very important for data acquisition purpose in the ocean model. We call the Ocean Global Model, OGCM. Ocean Global Circulation Model, particularly the Princeton Ocean Model, the regional ocean, the ROMS, MOMS. So in there, in situ measurement data is very important for the validation purpose and the other purpose. Particularly satellite data also gives a lot of information, and the satellite data needs to be assimilated to the ocean model. And also there are lots of ship cruises like National Institute of Oceanography, Geological Survey of India. They have their own ships and they regularly go for ship cruises and they collect a lot of data using in situ measurement. And also there are certain calibration site, calibration validation site. So whatever instrument you are getting, they need to be calibrated and need to be validated in some particular sites. So those functions are also there for this. So it is like a we call it integrated ocean observation system, where the space-based, the in situ based, the ship cruises, so they all come together. But nowadays also the drones data is also into the picture. So they will be all coming together and all the data integrated we will be using in various kinds of complex model to better understand our ocean. Now you see what are the YO capabilities or the Earth observation capabilities. If you see, you will be able to see, depending on the spatial resolution, your interpretation capability will be changing. So in this image, particularly the what I will say, this is the left hand, the top corner image. So this is satellite data we call NOAA aperture data that gives you sea surface temperature earlier. There basically you will find your resolution is 1.1 kilometer. So what you can see the Arabian Sea is going in a form of Gulf, in the Gulf of Khambar, in the landmass in Gujarat. But the same area when I am seeing with the IRS P4 ocean color monitor, having resolution 360 meter, you see more things you can see. You can see certain kinds of estuaries. You can see the mud flat, white salt encrusted mud flat. The red color basically representing certain vegetation. The water, certain water having more sediments, less sediment. Same area, this box I'm seeing in a AOE's data, 56 meter resolution. More features you can able to distinguish. Now this way it is coming. Then again this part, the square box I'm seeing in a LIST 23.5 meter resolution. Then the small part of this image I'm seeing it with a LIST for 5.5 meter. Then also you can see the finally I'm seeing in a cartosat and LIST for merged data, which is 2.5 kilometer. There's so many things you can map. You can map. You can see. You can see the various kinds of man-made structure, certain kinds of rounded structure, certain salt pans activity like mangrove you can see, certain industry you can see. So these very clearly those things are visible. So higher the spatial resolution, more your interpretation capability. But at the same time, higher the spatial resolution, your swath area will be less. Like if a big area, if you want to map, but if you feel that big area I'll be mapping, but I'll be mapping with a resolution of 1 kilometer or 1 meter or less than a meter, then you have to collect so much of data and so much of processing you need to do. So you have to compromise somewhere, like depending on how much area you are studying, what are the scale you need to map. Like if I want to map 1:50,000 scale, your LIST or Landsat TM, those kind of data having 23.5 meter or 30 meter is good enough. But if I want to map a urban area for urban mapping in 1:1,000 scale, then definitely your 50 meter or 1.1 kilometer or 360 meter will not help. They cannot generate a map of 1:5,000 scale or 1:1,000 scale map. Then definitely you have to collect sensor data which is having resolution less than a meter in centimeter scale, like QuickBird data or Iconos data or our own Kato data. Those kind of data you have to look forward. But those data, as I told you, swath is less. So in a single scene, it sees less area. But then at the same time, you can generate very high map having very high RF, like 1:1,000 scale, 1:500, or 1:5,000. But if I using a satellite data of like LIST 2 or earlier Landsat MSS, I can generate map in 1:250,000 scale only. So it depends on your project objective. It depends on what is how much your area. What is if I want to do the entire NDMA map of the Gujarat state, then definitely I will not go for a very high resolution data where IR band and the R band is there. I will go for a satellite data where IR and I is there, because NDMA had certain formula. So you need IR and R. At the same time, I need a moderate resolution data. So I will go for a LIST data or Landsat TM data or OLI data, those kinds of stuff I'll go for. Definitely, I will not go very high resolution because I have to process so much of scene. So this is what I'm telling. It all depends on what kind of objective your project is, what kind of map if you want to generate. So these are the certain examples I'm trying to show you. You see, this is how aquaculture plants has come up. Cutting the mangroves in Karinga mangrove forest in near Kakinada in Andhra. You can see there, these are all mangroves, the red color. This is the IRS only LIST and the PAN March data. But you see the mangroves have been cut and the aquaculture farms have come up. So aquaculture is artificial kind of fishing where you use a lot of fertilizers and prawn seed and other seeds you give, and they grow very fast, and you want a lot of foreign exchange. That's all fine. But no way you can cut the mangroves and degrade the coastal ecology, because mangroves comes under the CRZ1. So you cannot cut the mangroves. It's supposed to be there in the no development zone, and you cannot do cutting mangroves and doing certain business. Okay. At the same time, aquaculture is banned in this country now because it also creates a lot of environmental issue in the coastal area. So, but this satellite, what I'm showing you, this because I'm showing you this is the present scenario. This is an image of 1995. So now, if I want to see what is the scenario of 2020, now I can acquire data of 2020. Now I can using GIS, I can find out how much area of the total aquaculture. At the same time, in 2020, I can find out using GIS how much area. If area has decreased, then there is no issue. But if area is increased, if I have seen the more mangroves have been cut, then definitely that is a serious concern. Then you have to raise the issue in a proper forum. So this is the what the satellite data can help you out to study this. So this is the another image you can see. This is the high resolution data of the Alang ship breaking yard in Gujarat. This is the Asia's biggest ship breaking yard. So here see all the ships are standing, but this is not a port or harbor that they have come and they will go. They have come here because their life is finished for voyage, so they cannot go to the ship. So they have come here to break and sell the scraps. Okay, but at the same time, for breaking of a big ship, huge ship, they use a lot of oxyacetylene and other kinds of gases and lots of pollutant they are dumping in the coastal water. You can see the color of the coastal water on the satellite data. And this water goes further up from the Alang and they pollute the environment in the maybe 100 kilometer from the Alang. So this is the issues. But again, the ship breaking yard is a lot of money is involved. The local sets they hire the land, they auction the scrap material, and their ships are coming and they are being broken. Also, the Bangladesh in Chattogram, they have a ship breaking yard. So, a country like us, it is easy that all the, particularly all the rich countries and developed countries, they are sending their ships in our countries where we are earning money definitely, but at the same time at the cost of the very precious coastal ecology or the water quality. Seeing this, telling all these things, I will try to tell you that what is the basically how to control them. So that's why the government of India, Ministry of Environment and Forest has come up with certain kind of regulation. What you can do, what you cannot do in the coastal zone. How to protect our coast basically. So this notification came in the year 1999, where they divide the entire Indian coast into four categories. We call the CRZ1, CRZ2, CRZ3, and the CRZ4. CRZ1 and basically that CRZ boundary is basically it's a basically boundary which is 500 meter from the high tide line towards the coast area. So that entire area, the line in between high tide, low tide, and 500 meter from the high tide line toward the coast. So that entire boundary, which is called the CRZ boundary, and this CRZ area can be divided into four types. The areas which are ecologically sensitive and the area between high tide and low tide, they are called CRZ1, where no construction is permitted. Particularly the mangroves, the coral reefs, the mudflat, the sandy dune, the marine protected areas, they all come under the CRZ1. If you see the Government of India Rajpatra, the Gazetteer of Government of India, the entire permissible and prohibited activities is written over there in the CRZ notification 1991. Before 1991, where the notification came, there are certain urban areas which is already there in the coastal area. So we cannot destroy them as such and tell the people to leave. So they fall under the category of CRZ2. This is the area already developed close to the shoreline. So they are the CRZ2, that means coastal urban areas. CRZ3 are the coastal rural areas. They are relatively undisturbed. The fisherman village, the hamlets, small coastal villages. So they are coming under the CRZ3. CRZ4 is the Andaman Nicobar in the Lakshadweep Island. Special status has been given. So there are permissible and prohibited activities, but at the same time, you can see CRZ1 is the most critical areas where you cannot destroy the mangroves or coral reefs or other thing. But I will show you certain examples in your countries. Few examples I will give you. There are a number of examples where CRZ norms have been violated. You see, industrial growth in Gujarat has damaged the CRZ1 in the Gulf of Khambhat and so on. Mudflat in Maharashtra and the Kerala, mudflat is also CRZ1, are reclaimed. You cannot reclaim mudflat for the agriculture, industrial, residential, and the aquaculture, but it has been done. And satellite data you can use only multi-temporal satellite data where it was pristine mudflat, and latest satellite data you can see that mudflats are not there. There is agriculture practices going on, aquaculture has come up, industry has come up like this. Now, salt harvesting and aquaculture development are responsible for damaging the mangroves of Tamil Nadu, Godavari, and the Krishna region, and also in Sundarban. Mangroves have been cleared for the harbour activities near the Pandipur. So these are only few examples I have just told you. There are hundreds of examples in our country where the CRZ norms have been flouted. And also the various states of our country, because it's a federal structure, all the states didn't agree to follow this CRZ notification. So Government of India set up various other committees. So there was a committee called the Professor Saminathan's committee. So after that committee, there is a latest committee by Dr. Soiles Naik committee in the year 2014. Saminathan committee was in 2009. So various committees, their committees also certain issues. So the latest committee is 2014. The recommendation they have given, CRJ recommendation. They also came up with these 4, 1, 2, 3, and 4. But they've given a concept of the ecologically sensitive areas, geomorphologically important zones, archaeologically and heritage sites, which was totally missing in the 1991 notification. And also ecologically sensitive zone are very important. It is not that all the coast you have to maintain the same 500-meter line from the high tide line. Few areas may be ecologically not sensitive or they are not vulnerable. So it should not be the same. It depends on the how vulnerable the coast are. Accordingly, the setback line should be decided, and you can do your work. Okay, and so accordingly, the CRZ1 classification has been done. CRZ2, anyhow, this is the all developed areas near the coast. CRZ3, basically they divided the densely populated rural areas and the rural areas. Few rural areas is densely populated, so they will come under separate category than the rural areas. CRZ4 is basically they are giving the special category, which is these are the water areas falling below the low tide line, including the bed and the strata up to the territorial water limit. So up to the territorial water limit, that is the 6 nautical miles. They are falling under the from the low tide line to the up to the territorial water limits. They are calling them the CRZ4. So this is a simple map showing the CRZ boundary in the Panaji region in the Goa. If you can get the high tide line from the high tide line, you have to make a one-sided buffer for the from the land towards the land. You see the green, the yellow color is the buffer, 500 meter all the sides. So using GIS, simply I can make a CRZ boundary. But within this CRZ boundary, you have to classify the image showing the CRZ category, like this Panaji area, this sandy beaches, they are coming under the CRZ1. Where you are getting the mangrove coming under the CRZ2. The coastal villages, but the rural areas, they are coming under the CRZ3. Like this, you can make polygons and you can make the classification. For your information, I need to tell you that entire coastal erosion zone mapping has been done for in a national level by Space Application Center Ahmedabad in 1:50,000 scale, and also 1:25 large scale, 1:25,000 scale in selected areas. Few areas they have made the mapping in 1:25,000 scale as well. Now, next I was telling you the shoal line is one of the very important dynamic phenomena when coastal dynamics is concerned. Where is the shoal line? And the shoal line, you know, it is changing very fast. How I will understand shoal line from the field? This is very important. And in when from the shoal line demarcation from the satellite data is concerned, particularly or from the field it is concerned, we will always consider the high tide line is considered as the shoal line. That means during high tide, how much water is going towards the land. That is the high tide line. Okay, so during spring tide. That is a notification also in 2011 it has been given. So what is the field feature? What are the geomorphological feature for identification of the high tide line we see in the field? You can see these are the feature you have to look for. Maybe you will be going to the coastal area for in future some field work. So you need to know where is the where is the high tide line. So these are the feature like field photograph. You see these are the permanent vegetation up to here. This is the permanent vegetation. Okay, so this is the high tide line. The landward berm is the high tide line. The top of the seawall up to where the water comes during spring tide. This is the seawall. This is the high tide line. Two of the dune. So this is the dune. The base of the dune. This is the during high water comes up to this. So this is the shoal line. Base of the cliff, where there is a cliff. The base of the cliff is a shoal line. Also landward boundary of the mangroves. You will be considering them also as the shoal line. So these are the definition which you follow where the atlas of the coastal erosion activity is concerned. Their shoal line is shown in that atlas. There the shoal line, that standard definition is what I am telling you. From the satellite data, you can see how it is coming from the, and also corresponding field photograph is given. So this is a Gujarat, a place called Balana. So here you can see the base of the cliff has been considered. This is a cliff, base of the cliff, and in the satellite data, this is the area actually. This is the base of the cliff. So simply I will digitize here like this at the base of the cliff, and the other area it will go like this, and I'll find it out on the on-screen digitizing I can do, and I can get the height-height boundary. So this is again in some area in the Kerala. This is the
Excuse me, sorry, I have to just intervene. Here, this headline, the title of the slide that is being masked by one black dark patch, you know, in all the in the last few slides.
yeah, last slide.
नहीं नहीं, ये जो slide के ऊपर जो है ना, जो title जो है, that is being masked by something.
This is something coming presenting and
yeah, even in this also that there is a black patch.
Wow, 1 minute, just let me see.
Which is not showing the, which is
title.
masking.
Yes, yes. Now it is done.
हाँ, अभी ठीक है, it is okay. Thank you.
Fine, fine. It's okay. Actually, I was seeing this from my side also. It was there, but I was thinking it is only in my side. It is not going to your side.
Yeah. Thank you.
Okay. So this is the base of the vegetation, permanent vegetation. So this is the from the satellite data you can see these are beaches. How the beaches is the white color. It will come on the satellite data. So at the just after the beach where vegetation starts. So we'll make the boundary like this. So this is very important to demarcate the HTL from the satellite data. And there are a lot of algorithm, particularly nowadays available, like we call the NDWI or WI, water index, or normalized difference water index. Those kinds of indices will also help you to demarcate the boundary between the land and the water. This is the boundary with the land and the water. But actual land height line boundary, if you want to demarcate, then definitely you need to have certain information from the field. So you would look forward the base of the permanent vegetation. So here I'll get so vegetation is this dark patch. Then you can see the white patch, which is the sandy beaches. So in between this dark patch and the white patch, I will draw the line like this, which is the HTL. So like this, from the satellite data, we get to know about the lots of example I showed you from the satellite data how we get the height line boundary. Now in the ocean.
Excuse me, Mitra ji.
Yes.
So that means in a low sloping area, in a low sloping area covered with marshy land, swampy land, and this scrub kind of features.
Yes.
How will you be able to draw that height line just at the end of that scrub land? Or?
Yes. At the end, particularly at the end of the shrubs or the marshy land where it ends in the mudflat.
Okay.
Or in the sandy area where the mudflats are not there, where the sand beaches finishes and the permanent vegetation starts. In the cliff area at the base of the cliff. Okay.
Okay,
fine.
yeah,
so now
it requires field study also. It requires
definitely. I always tell my students that remote sensing, you don't sit quiet in the AC room in the computers and try to get everything. Unless until you go to the field, definitely there is a strong component of the field data. Even when supervised classification is concerned, when I try to do classification from satellite data, trying to extract various kinds of land use landforms, I need to go to the field. I need to have certain training sites because I have to finally see the classification accuracy. How much accurate is the classification? So that if you don't go to the field work, you will be only end up with the unsupervised classification. Computer will do its own classification based on the pixel values. That may not be accurate. You will not able to tell which is what, because sometimes on the image the things will be very confusing. You may think this is mangrove, that may not mangrove, that may be of some other coastal vegetation. So you need to go. You need to go sometime field. Certain training site is very much needed. Okay, sir.
Thank you.
Yeah. Now I'll continue. To understand when the as I know, the remote sensing consists of various kinds of band, particularly the visible remote sensing. You may be aware that we have a blue, we have a green, we have a red, we have a NIR. Those sorts of bands are there. Now, whether these bands will be helping us for getting any information regarding the depth of the ocean or even in the coastal zone, how much they penetrate. As I told you, on the land, the penetration of they are very less, but in the ocean they do penetrate. They have certain penetration capability based on the wavelength of the various kinds of remote sensing bands. Like red band, it has a certain wavelength. Like blue is 0.3 to 0.5, this 0.4 to 0.5, green is 0.4 to 0.5, red is 0.5 to 0.6, like this. So red light attenuates. That means it is absorbed very rapidly in the water. It cannot penetrate deeper than 5 meters. So if you are using only red band, you cannot get information more than 5 meters. Now blue can penetrate up to 15 meters, where the water is clear, where there is not much sediments are there. Because if sediments are there, they also will be just scattered back. Okay. If there is a clear water, then even can go up to even 30 meters. So up to 30 meters, I can get information regarding the depth, which is called bathymetry. The green light, the green band, they can penetrate up to 15 meters in the clear waters around the coral reefs. As I was telling you, where there are the corals, the water will be highly clear. So even I can go up to 30 meters using blue, and using green I can go up to 15 meters. So there are lots of study people are doing using remote sensing data for understanding bathymetry, because bathymetry is very much important, because for the navigation purpose, for various kinds of deep sea mining purpose and other purpose. And you know, the bathymetry usually we do eco sounding, and National Hydrographic Office situated at our place in Dehradun, controlled by Indian Navy. They are the nodal agency for giving the bathymetry map. We call now digital maps are available. We call the ENCs, electronic navigation chart. So they do survey, but it is not possible to do regular survey. Bathymetry is also changing with time, because they do regular survey only which are strategically important places like Gulf of Kutch, border with Bangladesh, border with Sri Lanka. The regular survey is being done, or if some areas, some ports are there, whether the deep ships able to come back up to the port side or something. Some private company also with certain permission, they do bathymetry survey across, does the dredging and other things. But whether remote sensing has certain capability to supplement those earlier old bathymetry charts, because there are certain charts which are old surveyed, like our SOI toposid, somewhere in 70s, somewhere in the 80s. By that time it is changed, but those areas are not of much importance from the naval point of view, so they don't update those charts. So satellite remote sensing definitely has a capability. There are lots of algorithms nowadays available, but all based on those band green and the blue. Lots of Lesengas principles are there. There are Stump's equations are there. If you see, even I will share you my email if somebody is interested to understand bathymetry of the ocean water, how to study bathymetry of remote sensing data. Please do get back to me. I can share various literature. Also, we do have published certain literature, some review papers on bathymetry, and I can share with you. So it has been seen that blue can penetrate up to 15 meters, green can go up to 15 meters, blue can go even 30 meters. And another important information is that near infrared penetrates to a maximum depth of 0.5 meter, and the infrared is fully absorbed. That means the sensor which has the IR or the IR band, NIR band, if you load on the IR band, it will not penetrate at all. It will be totally absorbed by the water. That means what will happen? If there is a water body, if it is the land will be having lots of pixel values. You will find there is a mangrove, there is a vegetation, there is agricultural land, there is a sand dunes, other thing. But what will happen to the water? Water, it will absorb the NIR. So it will showing the very black pixel. That means the contrast between the black and the land part, it will be very clearly visible. So land and water boundary, the IR or the NIR band is very, very important. And it will be working very nicely if your water doesn't have much sediments. If it has a sediment, definitely there are certain issues. The boundary will be a bit fuzzy boundary, because certain IR band, certain amount of IR band will also get reflected by the sediments present in the water. But if the water is clear, absolutely clear cut land and or boundary, if you load an image in Andaman Nicobar and the Lakshadweep, then you will be able to see. So even in the land, certain kinds of talabs, certain kinds of ponds, if you want to make the actual boundary of various kinds of water body, simply purchase the data or download the data, then which has a NIR band or IR band, and loads only a single band. You can see how nicely you can digitize those the water body. It is very nice, and that too, whenever there is a sediments are there in the coastal water, there are various algorithms are available how to overcome the sediments loads for getting better land and water boundary. It is not like that the sediments are there. It will definitely create a lot of noises. Definitely it will create noises, but there are algorithms available. It will be able to reduce the noise. So your result will be pretty accurate. So this is what I thought that I will share with you. This is very important information. If you want to take future projects for bathymetry and for this type of work, this will definitely help you out. So as I told you, from the ocean part, there are a lot of parameters you can retrieve, like ocean color, like ocean salinity, like sea surface temperature, sustainable sediment concentration. Same thing in the coastal area also. Using remote sensing data, I can do mapping of the mangroves, coral reefs, salt pan, aquaculture. Lots of study I can do in the fishery, particularly fishery forecasting and the monitoring. I can map the coastal geomorphology and the shoreline changes from the multi-temporal satellite data. I can find out in the ocean the areas of the upwelling areas, the eddies, the gyres, where from the bottom the cold water is coming with lot of nutrients and mixing on the top warm water. This is one of the important feature of the ocean dynamics. So those kind of upwelling areas can be demarcated very nicely from the various kinds of remote sensing sensor. As I told you already, coastal regulation zone mapping we have done. Suspended sediment concentration also IRS-P4 data, OceanSat 1, OceanSat 2 will give you quantitative estimation of the suspended sediment concentration. Using active sensor, I can do a lot of study for oil slick, wherever there is a dumping of the oil from the cargoes or the ships it is happening, or collision of the two tankers. We can map the areas where the oil spill has been happened, and also sometimes oil spill happen because of the from the bottom the structural trap or stratigraphic trap we call the geological traps. The petroleums are there, and from their traps also sometimes the petroleum comes and mix with the water. So, those places we can map with the active. They are the good for if you do mapping with the active sensor. Active sensor means which has its own source of illumination, like synthetic aperture radar data. Like Canada has a radar set, Japan has a JERS, India we have a RI set data, we call it. They are the active sensor data. So they are also important for a lot of ocean parameter study. They also give you information about the we call the you can generate wave spectrum. Wave spectrum will give you information about the ocean waves. It will give you information about the wave direction. It will give you information about the significant wave height. It will give you also the active sensor now give you information about the ocean bathymetry. Lots of studies being done for studying ocean bathymetry for using active sensor data. Also, the active sensor data will give you information about the well slick, the internal waves, also the land water boundary. So those type of all information also people are using active sensor data for the ocean and the coastal zone, as well as definitely the passive sensor, the visual remote sensing, which is rather easy to use. Particularly active sensor and the passive sensor, their processing is entirely different. The software is entirely different. Active sensor is a bit complex to operate because if you see the raw data, you will not able to understand anything. There will be a lot of speckles and everything. Nothing is clearly visible. But passive sensor data, definitely it gives more interpretive capability without doing much processing. Maybe a little bit filtering or principal component analysis you need. Otherwise, seeing only the image, you will be able to interpret so much of things. But passive sensor is a bit complex comparatively. But once you get expertise, that is also not a very difficult job, but also it has a lot of potential. It has a huge potential to do various studies. Also the chlorophyll, as I was telling you, from the ocean color data. So these are so much of information I can get from satellite data in the coastal zone and in the ocean. You can see from the multi-temporal satellite data, I can understand the dynamics of the coastal zone. You can see I have a here image of a creek in Surat. The left hand side is 1999. And the right hand side is 2003, and you can see the area which I have circle it. So the red color, this is a mangrove patch. This is a 1999 only scattered mangrove is there, but this is a very good sign. If you see the 2003, very good patch of mangroves has come up. So that means naturally good mangrove is coming up in the area. It is a very good sign because it is always better to conserve the mangrove or do afforestation. Okay, so new mangroves are coming up in the area simply using multi-temporal satellite data. We didn't do any processing, nothing. Only the data of 1999 and data of 2003. Same thing we have seen in the Bhavnagar area. You can see here the yellow part. This is the Bhavnagar Creek. You can see here the mangroves is decreased in the highlighted area in the particularly the eastern part of the creek. Here the 2000 data, you can see here the data is 2000, here is 2008. In 2008 eastern part the mangroves are very good, but if you can see in 2008 in the eastern part of the creek, the lots of mud deposition has happened over the mangrove. The mangrove has become less the area wise, but in contrast the western part of the creek, here the mangroves are, you can see here there's a scattered mangrove. Okay, and stunted growth. But here the lots of mangrove has come up in the other part of the creek. But satellite data is telling you only this much. Yes, these are the changes happen. Now, if you want to know what is the reason for this, why it has happened, whether somebody has cut the mangroves, whether something else is happening, why the mud deposition is happening in this area, whether the most sediments are coming from where, definitely you need to go to the field and do detailed analysis. But multi-temporal satellite data will definitely will help you out to tell what has really happened, whether what kind of changes happened, whether the, as I told you, whether aquaculture area has increased or mangroves have decreased, and all those stuff study. Like this type of study is very much possible. How the soil line is changing with time. This is the area of the Mahanadi estuary. How the soil line is changing. I tried to show you using Sarvapinda toposit map, which surveyed in 1929, and where I have digitized the land and water boundary, particularly the which has been shown in the yellow line, and at the backdrop we have shown the IRS 1D LISTRI image false color composite of 2001. So that is a difference between 70 years almost. Okay, 70 years data. You can see the new barrier island on the image, it has come up, but it was not in the toposit which was there in 1929. So this island was not there, so new barrier island has come up. So this is a spit. You can see that changes in the spit. Earlier spit was here, now the spit is here. So there is a total change in spit. Okay, so land water boundary, there is so much of shifting in the land water boundary. You can see here, this part is entirely this part which was showing in the SOI toposit, but now it is not there in the image. So this part is entirely getting eroded. So this is the erosion area. Here you can see the yellow line, it is now in the part of the land. So earlier land water boundary was here, but now you see land water boundary is going like this. That means here the new land has come up. So this is the area has accretion. So some area is getting eroded, some area is getting accreted. New island, barrier island has come up. The change of the speed has totally shifted. So it shows how dynamic the area is. Lots of dynamism is happening in this region. So definitely you can do very good study using a multi-temporal satellite data and how things are happening, and you can tell what is going to happen in the future using some predictive model. That type of study is also possible using this. So these are the, like I was telling you, that this part of getting eroded, this part of getting deposited. But also now it is possible, if you have a good amount of baseline data, you can do quantitative analysis of the erosion and accretion, and you can show the area, how much erosion has happened in this much of area, how much deposition has happened in this much area, where are the places where the erosion is happening. So there are certain statistical techniques. I will give you mainly two important techniques. One is called endpoint rate and another is the linear regression. There are other techniques called NSM, net sediment movement also. And this type of techniques are available. There is a software called DSAS, DSAS software that is along with ArcGIS extension it comes. So using this software you can do this type of study. So endpoint rate basically calculates, here for this you need multi-temporal soil line. So you have to collect historical satellite data, and you have to digitize the land and water boundary using certain kind of algorithm. And using this multi-temporal soil line, you will try to understand how the soil line has changed. So which part is getting eroded, which part is getting deposited. I'll tell you in a mota this much of that much of, so that you can understand and you can do further work at your end. So endpoint rate calculates the rate of changes in position between the oldest and the most recent soil line of a given data set. So it will try to understand what was the ancient soil line and what is the present day soil line. So using this in between, you try to calculate what has happened. Linear regression rate, basically it is the average rate of changes using a number of soil line position over time. So like you have a soil line of 1990, 1995, then 2000, 2005, 2010, 15, like this. So it will change in every 5 years gap how things have happened. So it is try to understand the average rate of changes using a multiple soil line. So the endpoint rate will use only the 2 soil line. Though you have a 10 soil line, it will be using the first soil line and the last soil line. But LLR will be using all the soil lines. Okay. But also one thing you have to remember, all the soil lines you have to extract it at the same tidal level condition. That is one of the catch in this software. So I will not go in detail. So this is the study we did in a Sagar Island. You can see the satellite data. This is a Sagar Island in the Bay of Bengal near Calcutta. So this island is eroding in various parts. So island is sinking also with time. So we tried to understand using this LLL rate, which part of the island is getting eroded and which part is getting deposited For this, you need to develop various kinds of transact from the baseline, and using this transact, it will calculate how the various parts is behaving with time. So with using this transact, there are in the index, finally using this software, you will get, see here, you see I have used the soul line of 1995, 2000, 2005, 2010 and 2016, depending on the availability of the satellites. And see all the red line, they are the values are negative. So all the negative values in the region, they are particularly where you are seeing the red line and the yellow line and light red line. So they are the areas where the erosion is happening. And all the areas, particularly blue line or the green line, which is very less over here except few patches. So they are the areas, the positive values, they are the areas where the deposition is happening. So like this, so this is a close up of this region, how the transits has been developed and how all the intervals lines have been created, and from a baseline, transits has been generated perpendicular to the, and these are the all lines, these are the all multi-temporal soul line, and this type of graphs can be generated. So this is a 0, line, the negative, the negative side here, this side the erosion, here the way the soul line is going in the up position, they are the deposition side, and these are the transact length. Okay, these are the different transact number 0 to 50, 50 to 100, 100 to this. So, and the different color represent different soul line. Okay, now I can generate, I can see the dynamics of the soul line, how the island has changes from the year 1995 to 2016, overall changes. Now, in between, how changes has happened in 10 to 16, 5 to 10, then 2000 to 2005, then 1995 to 2000. How changes? I can find out the total area in square kilometer, deposition in square kilometer. This much I find it out, and some this type of study can be done. So it can give you a holistic nature how the island is changing with time. So you can find out with time how this type of things are changing. I was talking you about a little bit of the future soul line prediction. This software also will allow you to predict how the soul line. This is the area in West Bengal coast, in Digha Mandarmuni coastal area, where we try to understand how the soul line will behave in 2050. So here you can see the 3 soul lines in the legend: soul line 2006, soul line 2015, and soul line 2050. 50. So 2006 soul line from the ancient data we analyzed. 2015 soul line also 2015 soul line we got, but 2015 we went to the field work with a RTK GPS, and we digitized the soul line on the field to understand what is the actual soul line and what is the soul line we digitized from 2015, and try to understand the soul line of 2050. Once we get the soul line from the field area, then I can estimate the errors in the model, and that bias I can calculate, and accordingly minimizing these errors, we will be able to predict the soul line of 2050. If you don't go to field work, particularly time in 2015 or some other coastline when you will be able to go to the field, you can use that soul line. At one time you should go to the field using with the RTK GPS. You should digitize the land water boundary or the soul line at a particular time. Then using that you should try to see how much error is coming when from the image you are extracting the soul line. So that much of error is there everywhere. That error has to be minimized. So that error you will calculate. We call the bias. So the bias has to be calculated, and that bias has finally, after calculating the errors, then I will be able to see what will be the soul line 2050. So because from 2006, then there will be 2 soul line. One is from soul line 2015 I am getting from the image. One 2015 I am getting from the field. So using 2015 and 2005 and 2015 the actual soul line, I am trying to see what should be the soul line using this model from 2015. So how 2015 soul line is matching with the actual 2015 soul line. So if it matches perfectly, everything is fine. If it doesn't match, that means there are certain errors involved. You have to find out that error, and that error has to be incorporated in this software, in this model, and using that error, minimizing that error, you will be doing the soul line of 2050. So you can see this is the green one is the 2006, the violet one is 2015, and this blue line is 2050. So this is going to the soul line. Once I can predict the soul line of 2050 or 2070 kind of thing, then definitely it will give you a certain idea of the coastal management planners or the people who will be investing in the coastal zone with certain industries or certain ports is coming up, how the soul line is changing. But one catch is, again I should tell you, that you should always remember this model will work perfectly. Like if there is no untoward natural incident, like if suddenly there is a huge tsunami or there is a huge cyclone, so those things have not been incorporated in the model. So if those things happen, then definitely this prediction of the future soul line will not work accurately. So it will having lot of error in that case because thinking that oceanographic condition, major oceanographic condition will be the remaining same. So then only this software has that difficulty, particularly if in between, like in 2015 and 2030, if something comes, then definitely there will be certain errors will be incurred. So this is what you can do the regarding future soul line for that. Biological oceanography, I will not give much importance. I will try to show you more on the saltwater intrusion, which is a major issue to concern, particularly in this region. This is a Gujarat coastal area. You can see they are the creeks, and here they are not aquaculture; they are the salt pans. So they are the creeks. Basically, during high water time, the water comes and they collect the saline water, spread over the field. During daytime, the scorching sun rays, the water gets evaporated and thin vinegar salt is ready. You can see even the mud flat, natural mud flat, when the water spread during high tide, when the water then evaporates, thin vinegar salt you can find out over the mud flat. So water is very saline in this region. But because of the semi-turbulent nature of the tidal condition in Indian coast, so if morning 6 o'clock is high tide, then evening 6 o'clock is the next high tide comes in this region. So in the morning 6 o'clock, if I cannot collect the water, then I have to wait for the evening 6 o'clock. But unfortunately, whatever may people are started pumping the groundwater near the coast for making salt, and that's the groundwater near the coast is very saline. So they are pumping groundwater to make salt for their own profit, without understanding there is a maybe the geologist they understand it is a groundwater geological issue, which is a formula called Gaivan-Hurwitz equation, where that is telling HS is equal to 40 HF. That is the famous formula. That means if your freshwater is because of the pumping, if your freshwater or saline water interface is lower by 1 meter, the salt water is come up by 40 meters. Okay, that means 40 meters salt water come up if you are pumping groundwater near the soil, that is the interface will go down by 1 meter, the saline water will come up by 40 meters. That means more saline water go deep inside. And as I told you, the using collecting water samples from the various villages. So they are the various villages. We collected water sample from the various villages, and we have seen the salinity content of the water is much higher than what is given by the European Union or the WHO as a potable water. The potable water should have the salinity content should be less than 250 mg per liter. But this water, you can see, we have made contours based on the salinity condition of the groundwater. You can see this the chlorinity content, the green color represent 250 mg per liter. The yellow one is 500 mg. The red one is 750. The violet one is 1000. That means all these village, Goga, Gandhi, Alang, that's what I was telling, Talatala. So they are with the people, they are drinking the saline water, which is having salinity more than 250 mg per liter. And if you go on drinking saline water more than 250 mg per liter for the long run, it creates a lot of adverse effect on your health, particularly for the kids. So, and this reason is mainly because of the unscientific ways of withdrawing the groundwater from making salt pan. That may give you money because making salt is a low investment, high yielding variety. We called it like this. So it gives you very easy money. But at the same time, we are creating a lot of issues on the coastal ecology and human health is concerned. So nowadays, particularly local NGOs, a lot of universities, they come up, they're trying to make people understand that this is not the way you're supposed to do it. If you want to make salt pans, you're supposed to collect water during only the high tide time. You cannot drink. And that too, as I told you, that exploiting groundwater in the area in between high tide and low tide is now totally banned. You cannot exploit groundwater for any commercial purpose. That can be only used, the potable water, for drinking purpose and for agriculture purpose. You cannot use them for any other purpose. Okay, so still that was using. And this contours are showing that how the scenario is this. Now, this type of study basically needs a seasonal analysis because pre-monsoon, the shower condition is different. Post-monsoon, there is a lot of showers happen. A lot of fresh water goes into the system. Then scenario will be changes. Particularly, we thought that if there is a good shower in some area in some year, then a lot of fresh water will go. Then and there are some area which are highly vulnerable for saltwater intrusion. They may be moderately vulnerable or low vulnerable. So we tried to collect data, particularly the subsurface data in this region from the Gujarat State Groundwater Corporation, and using a model called Galdik model, we analyze the scenario. So these are the, you can see these are the well location. So groundwater observation well location in the Bhavnagar district, and from this well location we collected data pertaining to groundwater, the data like total depth, the static water level, total TDS, the carbonate, bicarbonate, chloride, and this data we got from the Gujarat Water Resources Development Corporation for the year 1983 to 2003, every 5 years interval in the pre-monsoon season, May season, and the post-monsoon in the October season. So this is the satellite data. This is the area of the study. So this is the one block we didn't have any borehole, so we couldn't get any data here. But the other region, you can see the distribution of the borehole. It is very nicely distributed throughout the region. And these are the analysis we did using a Galdik model, where the subsurface geological parameter, particularly the aquifer type, aquifer hydraulic conductivity, height of the groundwater above sea, distance from the shore, impact of existing status of the seawater, thickness of the aquifer. That's why that name came, GALDIT. This is a model called Galdik model. So it's a very simple semi-empirical additive model. You can change the parameter depending upon the importance. There are certain weightages and ratings has to be given. Then the model will be running. Using the model, you will get maps like this on the vulnerability point of view from saltwater intrusion. So this is a vulnerability ranking of saltwater intrusion in Bhavnagar district. In the May 2003, you can see the red on this side is the ocean is in the right hand side. So near the ocean, definitely they are highly vulnerable. The red, all the area Bhavnagar, Gogamwal, they are the highly vulnerable. Then the yellow one is moderately vulnerable. Then the blue one is the less vulnerable, and there are certain areas they are not vulnerable depending upon the aquifer condition or the aquifer hydraulic conductivity or some subsurface geological properties. So water cannot transmit, so they are not vulnerable at all. So the saline water cannot move, or it cannot replace the groundwater. We don't know what is the reason, but they are not vulnerable at all. This is a scenario in the pre-monsoon season. When in the post-monsoon, we collected data again and we run the model. It has been seen that you can see that lots of area along the Bhavnagar who are highly vulnerable, they become moderately vulnerable. The less vulnerable area has been increased. The highly vulnerable area only remain in this pocket, and more area has come under the non-vulnerable area. That means if you want to do this type of study, you need to do in a seasonal manner. That means directly rainfall has an effect on this type of study. So we should see the scenario of pre-monsoon and the post-monsoon. Then you will get a very clear-cut idea what is happening in this region when the coastal vulnerability is concerned. You can see this is what in the GIS we did. All the villages we have put in the pre-monsoon and the post-monsoon scenario, which are covering under the chlorinity content more than 250 mg per liter. So these are the all village in the post-monsoon, which is drinking water having 250 mg per liter, more than 250 mg. And this is the pre-monsoon. You can see pre-monsoon more village, number of village more, so more village and more number of population. Here the less village after the shower and less number of population. But also the nowadays GIS, the population can go in as non-spatial data, and you can also study and you can generate pie chart. That has not been sent, but we publish the paper. Then we can generate a pie chart that before monsoon, how much of total population they were drinking water more than 250 mg per liter, and after the monsoon, what are the number of villages and how much population will be drinking the water more than 250 mg per liter. So this type of study is very much possible using, but here satellite data has less role to play with. It is more a model kind of work, and the subsurface well log data is needed. But this type of study is very much possible. But if you want to do, even if you want to see the effect of salinity using remote sensing data, we have seen in this region there is effect in the long run on the vegetation. If the salinity is increasing, there is effect on the vegetation, and that can be, you can understand using long-term NDVI values. NDVI is a basically normalized difference vegetation index, NDVI, normalized difference vegetation index. The formula is IR minus R by IR plus R, and its values ranges between -1 to +1. More the value towards the +1, more healthy the vegetation. And water is value negative, and towards -1, water will be the value, and more value towards the 0. That means vegetation health is very poor. Okay, so this is an index which is talking about the health of the vegetation. So if you go on continuously monitoring this region in a multi-temporal NDVI values, you can be able to see that because of increasing salinity in the region, in the groundwater salinity, the vegetation becomes stunted, and also the chlorophyll content on the leaves have been affected, and which can be clearly reflected by the multi-temporal NDVI. So that study can also be taken up by any time in any region where you feel that there is a instances of saline water intrusion. So that area you can do. This is one study. Now I will go my last case study, which is a very interesting when remote sensing is concerned and the ocean is concerned, particularly which has been used for the common man use. One of the success story of remote sensing is locating the fishing ground in over the ocean. Earlier, the fishermen used to go to the field without having much scientific information where they will get the fish. So what they used to see, where the birds congregations are there, what is the top of the ocean color, there the bubbles are barking over the ocean surface, the muddy and oily and the calm sea, where that means they are the indication of the fish. There is a reflection in the night is coming up, or there is a certain kind of smell is coming up from the ocean surface. So they are the traditional indication by the fishermen on the sight, smell, and hearing. But often the fishing team resulted in spending longer days at the sea and return with low and the no catch. Sometimes there used to be low catch or the no catch because very low or no, because there is no scientific basis on this type of information. So basically, if you get a good catch, they used to tell this is the luck of the fisherman. This fisherman is lucky, so that's why they have get good. But of late, it has been seen the satellite remote sensing data has a role to play with of the fish agglomeration, like where the fish's chances of getting fish is more. Because fishes are basically they will agglomerate where food is there. It is not for fishes, everybody is. For human being also, food is there, people will go. So where you will get the fish for the food? They are the small microscopic plant. I told you phytoplankton. There's a chlorophyll. I can understand chlorophyll from the satellite remote sensing data on the ocean color monitor. And another one is the temperature data from SST map, which can help you to get the areas for identifying the gyres, eddies, filament. Those areas basically you can identify from the SST map because they're the areas for the thermal gradient. Why there is a thermal gradient? Because the gyres and the eddies are the region where from the bottom, because of the ocean dynamics, for various other reasons, from the bottom the cold water with lot of nutrients, they're coming and mixing with the top warm water. So there is a thermal gradient will be happening, and the bottom water is coming with lot of nutrients. So fishes will be chances of getting fish is more of the region like eddies and the gyres and filaments. Okay. So that earlier when National Remote Sensing Agency that day when they were doing the PFZ mapping, that time our ocean color monitor or OCM was not there. They used to do with the SST map using NOAA AVHR data. It is the American satellite data having 1.1 kilometer spatial resolution. From that they used to get those type of map, filament, gyres, eddies. You can see. But when OCM came, I started added the chlorophyll along with the SST map, quantitative analysis of the chlorophyll. So my accuracy has been increased. Now also it has been seen the PFZ font, the changes with the time because of the wind. So SSW, sea surface wind, is also one of the important parameters. So we started incorporating sea surface wind. So I will just tell you from this diagram. First, we will do the atmospheric correction of the ocean color monitor data. There are certain biooptical algorithms available from for OCM imagery to get the chlorophyll map. So I will get a chlorophyll map. NOAA AVHR data, there are techniques called split window techniques, which will give you the SST map. So I am getting chlorophyll and the SST. The wind data I am getting from a sensor called QuickScat. I am retrieving using certain algorithm the wind vector. So I am getting the SSW map. So using chlorophyll, SST, SSW, I am getting PFZ composite map. So these are the various fishery sector in India. You can see almost all coastal states have been covered. So this is a sample image of the sea surface temperature. This is a sample image of the chlorophyll. 1 minute, I will have some more. And as I told you that chlorophyll, basically you will having more chlorophyll concentration in the coastal water. That I told you at the beginning of the class. And more you go to the open ocean, the chlorophyll concentration will be diminished. That's the majority of the fish catch will come from the coastal water. And these are the EDs, how they will look like on a SST map. So these are the you can see ring-like structures. They're the EDs, they're the meanders, upwelling front, rings, filament. So they are the features which we'll be looking for. So earlier we used to look for these features and give the fishermen. But afterwards we have the SST, now SSW, accuracy has been increased more than 80%. And these are the display board which will give you the PFZ information in the various fish landing center, in the fishermen places. But one question always comes if you go on catching fishes like this, whether the fishes will be sustainable in future or not. So that is why, as the entire this PFZ procedure are using OCM, Ocean Column Monitor, that means OceanSat 1 or OceanSat 2, or the NOAA, they are the passive sensor. So if the clouds are there, they will not able to give much information. So that's why, and also the rainy season where clouds, that time clouds are there, also they are the breeding season. So breeding season for making a sustainable stock, we don't give any PFZ map. Okay. So in view of the cloud cover during the monsoon season, and more importantly, this season corresponds to the breeding season, the PFZ advisories are not provided during the June-September in order to maintain the fish stock at a sustainable level. And these advisories are prepared in the local languages because sometimes fishermen may not be able to read English or the Hindi language. So the local languages, this advisories are prepared and they disseminated thrice in a week, Tuesday, Thursday, and the Saturday during non-band and the cloud-free days. Dissemination of information is through innovative and novel initiatives such as electronic display board, which has been shown to you now. And also it has given in the information booth at the fishing harbor through radio, print media, email, fax, telephones. So before the fishermen go to the fish, they have a PFZ map with GPS, so they know where are the places where chances of getting fish are more. So these are the PFZ map. You see the black line is the PFZ contour, the dotted line is the bathymetry maps getting from the NHO charts. So these are the bathymetry contours. The solid line, they are the PFJ contour. So PFJ contour, these contours are basically valid between 2 to 3 days maximum. You can see this is the PFJ contours from using SST and the chlorophyll map. The SST on 31st December and chlorophyll is on 1st January, and it will valid till January 4th. So maximum 3 days. January 1st, I am developing it. January 4th, it will be valid. If you go after January 4th, that font will be shifting. Okay, the font will not be here where it is now. Maybe it may shift towards this direction. But how much it will shift, where it will shift, that information, though it will be not very, very accurate, where the initially time the PFZ will be generating, but still you will get certain fishes. For this, you need SSW, sea surface wind. So that also information nowadays is available, and I will show you the shifting nature. So using this type of maps are developing from a lighthouse, which direction they will go, what are the latitude, longitude, and what will be the depth of that particular place where they will go to catch the fish. So this is the shifting feature, SSW. So this is the PFZ map using satellite data on 11 January. So this is valid on 14 January 2011. So after 14 January, if you go, so this contour will be shifting over here. This contour is shifting over there. This fellow is shifting over there. So shifting nature of the contours is also shown. So how they are going to be shifted with time. And for validation purpose, people may ask how to validate. For the validation purpose, the FSI, Fishery Survey of India, Fishery Survey of India, the fishing vessel has been used. And so there are two vessel has been done. One is, you can see, MRR 8, which is going to catch fish in the PFZ area, and MRR 10, which is going to catch in area where there is no PFZ contours are there. Now finally, comparative tables have been given catching fish in PFZ and non-PFZ, you can see the finally total catch in kg. It is written in the PFZ area. It is 7,200 kilo, and in non-PFZ 1,800 kilo. So finally, that means what? That means net profit will increase. Here the net profit is 2,82,400. Here net profit is 68,500. Obviously, because you know the place, if you where I go to catch the fish, your diesel consumption will be less, your total travel time will be less, everything will be less, and you will get good fish. Finally, what is happening? Your final profit is being increased. So now the quality of the fishermen will be also be enhanced, so they can lead a good life. And also this type of another like MDF and SLB, another two vessel, the study has been made. And again, the same story, PFZ map is 11,64,000 and the non-PFZ map is 5,73,000. So this type of validation work has been carried out. Now, I will tell you, this will be my last slide on today's lecture. We have a certain, that means this entire program now, the algorithm has been developed by National Remote Sensing Agency and Space Application Center. Now, entire algorithm, the entire process has been now given to NQuest, which is there in Hyderabad, Indian National Ocean Center. So, NQuest in Hyderabad is operationally sending the PFZ map to all fishing locations. Okay, so entire operation is now being maintained by NQuest. Even if we see that this PFZ map, this display board is also here. It is written Indian National Center of the Ocean Information Services, NQuest. So this is comes under the Ministry of Earth Sciences, Government of India, located at Hyderabad. So entire plan is now being monitored by them. After doing the required algorithm and other things by Space Application Center and the NRSC, it is called the transfer of the technology. Technology has been transferred to them. Now, what is the future plan for this PFZ basically? Now, in future, it has been thought that whether it is possible to give them the specific PFZ, like if some fishermen or some community is interested to catch the tuna, somebody is mackerel, whether it is possible to give the specific PFZ map. If I can able to give a specific PFZ map, then obviously I will be able to know what kind of vessel I require, most suitable vessel I can select, most suitable gear I can select, fishing technology, the fishing net, because different fishing net is there for different kind of fishes. So if I first time I know I am going to catch the tuna, so I will be knowing what kind of vessel I will be getting, what kind of gear I need to get. So the improved technology, incorporating the SSW also, it will enhance the chances of up to even 85%. In the near future, the PFZ forecast will also harness the information on sea state, tide, current, and the wind condition, which will help fishermen to reach the PFZ site safely and in the shortest time. Now they have the map, they know this is the PFZ site, but we should try to help them to tell which route they will go, which is the shortest route. And if I get to know them the sea state condition, there are lots of models available to understand the sea state condition beforehand. Also, this type of models are there with the NQuest and the other oceanographic organization in India. So if they get to know, they will be able to reach safely also. It will be safe. If somewhere there are certain storms will be coming or certain wave heights will be there, they don't go with a big ship. So their life will be endangered in this case. And now experiments are underway to provide forecast straight to the fisherman vessel through satellite radio. So nowadays it is government is thinking that without taking the PFZ from the fish landing station where they go to catch the fish to the ocean, if it is provided directly to the fishing vessel through the satellite radio, directly in the vessel at that particular time in a real time mode, if it is possible to send to them. That is another areas where people are working. So I think I'll stop. It is now 4:40. So if you have any queries to discuss, I'll be happy to discuss with you all.
Participants, if you have question, you can ask or any doubt. Yes.
though it is a marathon lecture, lots of things has been being covered, but unfortunately, I am helpless because there are so many things when ocean dynamics and coast is concerned. So, and also the climate change. So I thought, but anyhow, my mail ID you can note down. I am mitra@irs.gov.in. If you have any queries, any further, yeah, as I told, if somebody is using wants to go for bathymetry study, further study, research on bathymetry, your student want to do PhD on bathymetry, I have certain information on bathymetry, some publication, what we have done. Lots of people are using now, so I can share with you. Absolutely, there is no problem. mitra@irs.gov.in.
Any question from participants?
If there is any queries from the participant sides, though I don't know the participants background, but they are all faculty, it seems. So if somebody is interested on ocean and the coast or the geology, coastal zones, saltwater intrusion, they are the areas where they can work.
Hello, sir.
Yes.
Namaskaram, sir. So my name is Ashmita, and sir, I want to little bit more about. You have shown one slide where you have predicted the shoreline positions. That is for 2050. So can you
Yes.
please little bit elaborate this? How you done the prediction part?
The prediction part is a basically model derived output. I told you, you note down there is a ArcGIS extension called DSAS.
Okay, sir.
You note down this name. There is a DSAS software. It comes along with the ArcGIS extension. You have to install it. You have to install it in your computer, and there are various methods. I told you LLR or the EPR. Any techniques you can adopt. And you have to have at least 2 years shoreline digitized. So one, let's example 2006, and one shoreline, say let us example 2021, and you want to predict 2030. So in that case, what do you have to do? First, you predict using 2006, 2021. But how accurate is your 2021? You need to go to the field with a GPS, kinematic GPS, where you can digitize on the field itself, RTK GPS. Okay. And you actual field shoreline 2021 a sector. Maybe you will not able to cover the entire shoreline in a field work area at a particular time. So in a small sector, only for getting the bias, you digitize using the RTK GPS, and you see the what is the shoreline which is coming. One you will get from the software 2021. One you are getting from the actual shoreline from the field, and you just compare these two shoreline and try to see how much error has been incurred. That there are provisions that error has to be incorporated in the software, in the model. Then you once the error will be incorporated, your next output will be less error. Then using that, you can predict the 2030 or 2040. Okay, but every steps, everything is there in the DSAS. You can install DSAS where ArcGIS is there.
Okay, sir.
But you have to have, always remember, you have to have at least 2 shoreline.
Yes, sir. Sir, then you have shown one LLR shoreline. So there, I think we need more than 2 shorelines. So
yeah, LLR is only to understand the coastal erosion, quantitative analysis of the coastal erosion, and how much any island or area has been changed because of the erosion and accretion.
Okay, but for prediction, at least we need at least 2 shoreline to
at least,
predict.
yes, and also one field campaign.
So all of you come prepared.
Hello, sir.
Yes.
Okay, sir. Thank you, sir.
Any more question? Participants?
Sir, can I ask one more question?
Yeah.
Yes.
Sir, you showed that chlorophyll and in ocean that chlorophyll we can catch through satellite. Sir, which software we can use for that? Is there like normal?
Yes. There is a software called SEDAS.
SEDAS.
SEADUS.
Sir, SEDAS. Okay, sir, SEDAS only we can use Linux, or it will be out for Windows also? Nowadays
Windows is available. Earlier it was Linux, but if you use ocean color monitor data, nowadays algorithms have been developed by Space Application Center and also by National Remote Sensing Center. So you can get algorithm from them also. And also, if you don't want chlorophyll to be extracted, nowadays geophysical product as a chlorophyll from ocean color data readily available. You can get chlorophyll map.
Okay, sir.
You can get chlorophyll map, you can get SST map, you can get KD map, attenuation coefficient map directly as a geophysical product. You need not to, if you want to do research, fine. Otherwise, if you want to use chlorophyll from other purpose, you need not to struggle. You can get directly as a geophysical product from NRSL.
Okay, sir. Okay, sir. Can we get the same thing from Vedas?
You will get from MOSDEC.
Okay, MOSDEC. Okay.
And also, yeah, MOSDEC you will get.
Okay, sir. Thank you, sir. Thank you so much.
So can we conclude now this session?
Yeah. Yes.
Sir, thank you, Ms. Mitra sir, for delivering this very interesting lecture on ocean dynamics and coastal zone dynamics, and overall covering all the areas related to ocean and coast dynamics. So thank you, sir, for this very interesting lecture and accepting our invitation to deliver a lecture in this. So in the future, we will be in touch.
Yeah. It is my pleasure to interacting with you all. Thank you. So may I quit now? Is okay?
Yes, sir. Thank you.
Thank you.
Thank you. So participants, we have come to this 4th day of this Atal FDP, and tomorrow is the last day of this Atal FDP, and your we'll be seeing your attendance, and tomorrow will be a session where we will be expecting some feedback on this 5 days FDP, as well as there will be a test that is requirement of AICT for giving you the certificates. So please go through all the lectures, whatever you have noted down, your notes, etc., so that you get good marks and you get ultimately the certificate from AICT. So tomorrow you join the session. First session is 9:30 again in the same time, and then there will be one more technical session, and the third session is valedictory session. There we'll have the test and feedback, etc. So again, thank you for hearing patiently, for your patience hearing and your everything. Thank you. So we'll meet tomorrow. Okay. So I'll be sending you the link, etc. So thank you, sir. Thank you, participants. Thank you all. So,
thank you, Professor.
thank you.